Circles, they're fundamental to most of the things we do in mathematics, so let's take a deeper look into them. First, let's look at some definitions to do with circles. First, lengths. From the center of a circle, the distance from the center to the circumference is the radius. The length that goes through the center from one part of the circumference to the other is known as the diameter. Then, a line which connects any two random points on the circumference is known as a chord, which actually makes the diameter a special type of chord. It's only just that it goes through the center as well. Now, the last length we can talk about is the perimeter of a circle, or the distance around, is known as the circumference. Some other definitions we should be familiar with is that, remember, around the circle, the distance is the circumference. Now, a portion of that circumference we call the arc length. Yeah, so some proportion of the full length is known as the arc. Also, we have the area of a circle, obviously, but if we were to chop a piece away in the shape of a cake, maybe you could say, we call that a sector. And one more definition is, remember, the chord. The area that is produced by forming a chord is known as a segment, which technically means then that a semicircle is also technically a segment. Let's next take a look at the area of a circle. Now, the earliest known individual who experimented with this was Archimedes. And what did he do? He took a circle and he drew a square around it. Now, guys, I've done my best. Comment down below. What do you think about my circle and square? Anyway, I'm going to take a circle with radius r. And I know that the area of this circle must be smaller than the area of this square. Now, what are the dimensions of this square? Well, if this is r, the radius, then the other side must also be r, the radius, which means this whole length must be 2 lots of r. Remember, the diameter of a circle is equal to 2 times the radius. So this length here is 2r, which means the square has length 2r. And this would also be 2r. So what's the area of the square? Well, we're going to do 2r times 2r. 2 times 2 gives me 4. Then we have r times r. Remember, we did our indices together. R times r is r squared. Now, the next thing we're going to say is, what must the area of the circle be bigger than? And what Archimedes did was he drew a square inside of the circle. So within my circle now, I have drawn a blue square. Remember, my red square was 4r squared. Let's find the area of this blue square. Now, remember, this is still the radius, and we know this distance is also the radius. And this is now a right-angled triangle. How do we work out the area of this triangle? Well, we do the base length times the height, then we divide it by 2. R times r, remember, is r squared. Then we have to divide it by 2. Dividing by 2 is the same as halving the number. Now, that's this area. How many of these triangles can we form? There's 4 of them. They're all a half r squared. So in total, how much is it? What's a half plus a half plus a half plus a half? The answer is 2. So the area of this blue square is 2r squared. And what Archimedes did was, instead of doing a square, he then did a pentagon within, because that way he could get closer and closer and closer to the area of a circle. And what do you notice about these two numbers? There's a number in between which will allow us to work out the area of a circle. So we can conclude that the area of the circle is going to be some r squared. But what is this constant? It's a number between 4 and 2. And with more iterations of drawing a pentagon, then a hexagon, etc., we find a number that is between 4 and 2. And that number, guys, is pi. And that's why the area of a circle is pi r squared. Let's do an example. So here I have a large circle with a smaller circle inside. Now this smaller circle goes through the larger circle's center, and this smaller circle has radius 2. So how are we going to find this shaded region? Well, simply what we're going to do is find the area of the large circle and take away the smaller circle. So let's call it large. Remember, the area is pi times the radius squared. But what is the radius of this large circle? I haven't written it down. But since the blue circle goes through the center, I can work out its radius to be 4. Because if this is 2 and this is the radius of the small circle, then this distance must also be 2. So it must mean that this length here is 4. So it's pi times the radius of 4 squared. What is 4 squared? 4 squared is 16. 16 times pi, we can just leave that as 16 pi. Now what about the smaller circle? We can say pi times the radius of 2 squared. 2 squared is 4. 4 times pi, we can just write it as 4 pi. So finally, the shaded region is the larger circle, 16 pi. Take away the smaller circle of 4 pi. 16 minus 4 is 12. And then we can continue writing pi. Guys, before we move on, please hit the like button if you're enjoying and subscribe for more content like this. The next thing is the circumference of a circle. Now we can structure it in a very similar way where we have our circle, and I'm going to approximate this circumference by drawing a square inside and finding the perimeter of the square and saying that this perimeter is an approximation of this distance. Then I'll explain what we do next. So the first thing we need to ask ourselves is, how do we find the length of one of these sides? Well, we can see our right angled triangle, right? It should remind you of something, and that is Pythagoras' theorem. How do we work out this length? So I'm going to redraw the triangle. So we have R and R. And we're going to do Pythagoras' theorem, which is a squared plus b squared is c squared. So we have R and R. So R squared plus R squared is this unknown length, c squared. R squared plus R squared is 2R squared. Now the last thing we need to do is we need to root both sides. Now if we root both sides, we just root everything. So root of c squared is just c. Root of R squared is just R. Now 2, there is no integer that multiplies by itself to give 2. And this is where we come to something known as surds. And we say root 2. We don't actually evaluate the number. And you can type in your calculator what this number is. So this length here is root 2r. So my perimeter of my square, and I'm going to write this in a specific way because you'll see why I'm going to do that. So it's root 2r plus root 2r. Now what is that? If I write on the top, root 2r plus root 2r. It's just similar in terms of algebra. So root 2 plus root 2. Root 2 plus root 2 is 2 root 2. So I have 2 root 2r. Yeah, that's this distance. And then I'm going to double it. So I'm going to times that by 2. Now the reason I've done this is because of this here. R times 2. What do you know is double the radius? You know that's the diameter. So we get 2 root 2 times the diameter of the circle. Now, we can type this in the calculator. Let's see what it gives us. It gives us 2.828, etc. times the diameter. Now remember, this is a very bad approximation to the circumference of a circle. So what we would do next is we would next do it with a pentagon, which is much closer to the circumference. Then we would do a hexagon, we can go octagons, and we'll keep doing different iterations. And at the end, our shape will be very, very, very close to the circumference. And this number will continue increasing to our very special number, which is very close to 3.14, which is pi times the diameter, which, guys, is the circumference of a circle. Let's take a look at an example. So, below is a window frame in the shape of a semicircle. Find the perimeter. And I've given you that the radius is 40. Now remember, semicircle meaning half a full circle. So what we need to do is find what this distance is, which is half of the circumference of a full circle. So my circumference is pi times the diameter, where if the radius is 40, the diameter, if this is 40 as well, will be 80, which is 80 pi, which means this length then, we need to divide it by 2. Therefore, for the semicircle, it will be 80 divided by 2. 80 divided by 2 is 40 pi. But we're not done yet. My final perimeter then will be 40 pi plus 80. So 40 pi plus 80. Now in maths, we can keep the exact form, but if we were to type into the calculator, we would have to approximate it, and it would give you about 206 centimeters to the nearest whole number. Now, where are circles used in real life? You only need to look at your clock to see it's hopefully in the shape of a circle maybe. If it's not, you can look at the hands, and they move in a circular motion. We also have design and architecture. Circles might be used for aesthetic appeal, space efficiency, and structural strength. Where else can we use circles? The wheels on the bus go round and round. You can look at planes and the jet engines being circular. You actually can look at the windows as well. They're in a circular shape. They're not just straight, and this is to prevent stress concentration. So guys, this is circles, extremely important. If you enjoyed this video, please hit the like button and make sure you're following me for more. Nice.